The caveman diet you've heard about is mostly a marketing myth. When people imagine early humans eating, they picture a dramatic mammoth hunt, spears flying, meat piled high. Freeze that image and rewind. Big hunts make great stories, but they were rare, risky, and unpredictable. Miss the animal or lose a hunter, and the cost was huge. No group could survive by gambling every meal on a single kill. Day-to-day survival depended on reliability, and that usually meant smaller, steadier foods. Think baskets filled with roots and tubers dug from the ground, nuts cracked open with stones, berries picked in season, seeds, insects, shellfish, fish, and small animals. These foods didn't require weeks of tracking or perfect coordination. You could gather them today and often again tomorrow. This plant-heavy reality is easy to miss because of a bias in the archaeological record. Bones preserve well. Plants usually rot. One large animal can leave a dramatic pile of remains that lasts for tens of thousands of years, while years of gathered greens leave almost nothing behind. The fossil record isn't a menu, it's what survived. But plants did leave evidence, just not where people expected. Ancient teeth carry receipts. Hardened plaque, called dental calculus, traps tiny food particles. Under a microscope, scientists find starch grains and phytoliths, microscopic structures made by plants. These show that early humans, including Neanderthals, ate roots, tubers, seeds, and even wild grains far earlier than once thought. In some cases, those starches show signs of cooking. Teethware tells the same story. Gritty, fibrous foods leave different microscopic patterns than soft meat alone, and the patterns we see point to mixed diets, often with significant plant processing. Tools back this up. Stone tools weren't just for killing animals. Many were used for digging, pounding, cracking, and grinding. That's the kind of work you do to turn tough plants into food. Wild tubers can be hard to chew and hard to digest. Nuts can be locked behind shells. Seeds often need grinding. Without tools, many of these foods aren't worth the effort. With tools, they become dependable calories. Fire changed everything. Cooking breaks down tough fibers, gelatinizes starch, and makes both plants and meat easier to digest. You get more usable energy with less chewing and less work from your gut. Fire didn't turn humans into carnivores, it turned them into better omnivores. You might hear that chemical evidence proves early humans ate mostly meat. That comes from isotope analysis of bones, which tracks where dietary protein came from. Here's the catch. Isotopes reflect protein, not total calories. A person can get most of their energy from plants, but if their protein comes mainly from meat or fish, the isotopes will look meat-heavy. That doesn't mean plants weren't doing a lot of the fueling. Zoom out and the bigger pattern becomes clear. There was no single ancestral diet. Diets changed with geography and season. Coastal groups relied heavily on shellfish and fish. Forest dwellers ate nuts, fruits, tubers, and small game. Grassland populations mixed plant foods with large herbivores. In cold or glacial environments, plants could be scarce for much of the year, so meat mattered more. Same species, different place, different menu. Even within one location, diets shifted month to month. Spring greens, summer berries, autumn nuts, winter hunting, or stored foods. Flexibility was the strategy. So the lesson isn't to eat like a caveman. Prehistory wasn't a rule book. Humans succeeded by being adaptable, by using tools, fire, and knowledge to turn whatever the landscape offered into food. Our ancestors didn't follow a diet, they followed the seasons.